This has been already a pretty long lecture, so we're going to wrap up with a very quick review of joins, which we invite you to explore on your own in more detail. So we'll start by trying to load data from a zip file that is included in the folder. And one thing that we want to point out is how Python makes it possible for you to access zip files without actually uncompressing them. So Python contains a zip file object that lets you actually see what's inside of this zip file. It contains 2 CSV files, and importantly, it allows you could unpack that by calling extract all. It would actually uncompress the zip file, but Python actually will let you go and read an individual CSV with read CSV without ever uncompressing the entire zip archive. And that can be really useful if you have a very large zip file that contains lots and lots of stuff on the inside, and you simply want to pull a piece of data. You don't have to clutter your hard drive with exploding it, but instead you can go ahead and read the data from it directly. So this is an example that we're going to use to illustrate how merge works, how the Pandas merge method works by taking 2 different data sets about elections. Our previous one, elections.csv, and one that contains some biographical information about presidents, such as their date of birth, and the period they were in office, their birthplace, and their state of birth, but it doesn't contain any election data. This is just about presidents. And so we can join them by for example, in this case, doing an inner join between the elections and the president's data sets. So elections is this one right here, presidents is this one. But importantly, we have to observe that the name of the president is named differently in the 2. Right? In the elections data set, it's called candidate, because this one is actually a full elections data set that contains not just the winner, but every candidate who participated in an election, whereas the president's data set only contains the actual winning presidents, and so the same people appear under or labeled differently, and so we specify that, and let's see what happens. This is the data set. This is the data set that results, and there's a few things that I invite you to play with this, to kind of scroll through it, and notice a few things. For example, first of all, because we asked for an inner join, it only contains rows that have names in both tables, but we don't find presidents before 1824. So if we look in here, we see that there are no presidents before 1824. So George Washington actually doesn't appear. And the reason is because there was no popular vote before 1824, so George Washington is not listed in the elections data set. The name Andrew Jackson occurs 3 times in the election table, and it also appears 3 times in the output, but Grover Cleveland actually occurs 6 times. And that's because he appears 3 times in the elections table, but twice in the president's table. So we get the cross product of that. We get all 6 combinations. And then finally, it's worth noting that the data hasn't been cleaned up. And so even the same person, for example, JFK, is listed in the elections table as John Kennedy. But in the president's data set, he's listed as John F. Kennedy. And so the algorithm isn't going to identify that as a matching key and will not fill that row with the union of the data. And this is a really important point, is that you need to know the structure of your data. And if you're going to do these kinds of operations, you may first need to do some manual cleaning. There's a lot of work in data science that involves massaging and fixing and adjusting your data so that later your tools can process it correctly and cleanly. And there is no magic bullet for this. You have to understand your data. You have to know what caveats and peculiarities your data sets have, and potentially go and manually fix them. Because if you don't, the tools are not smart enough to do that for you. There is actually research in tools that help do some of these things in a semi-automated manner or detect some of these problems, but this is not something that Pandas will do for you automatically. So with this kind of machinery, now we can do things like, well, let's grab this exact joined data set, and let's ask, for example, what was the age of each president when they were elected? And a couple of lines of code will give us that. And so now we can let me just remove that output object. So here we can use quickly Seaborn to do a scatter plot of per year the age of all the presidents as on the year that they won the presidency. Now, Seaborn by default makes a fit. In this particular case, having a linear fit to this is not particularly illustrative or informative, but this is what the Seaborn LN plot routine does by default. And we'll revisit more visualization in future lectures. So now, how could we fix this issue with the duplicate Grover-Cleveland issue? Well, if we call after the merging, we do a quick group by, then we can actually say, give me the first occurrence for, since we're looking at let's see here as well, where's Grover-Cleveland? Over here, right? Grover-Cleveland is appearing with duplicates for the same year, right? He's appearing twice, and this is the issue that we're trying to fix. Then we can say, well, grab me, if we group by candidate and year, then once that key is unique, we can say, give me only the first one. And so by saying grab first, we can now have, here it is, we can now have a single occurrence of Grover-Cleveland. And finally, you can construct not just inner joins, but outer, right, and left joins, which will give you, in each case, the semantics, effectively the SQL semantics of those joins. Here are all the three, and so if we wanted to keep all the presidents and leave missing data for years when there's no popular vote, we can do that. We can do that with a right join that is going to include every row from the right data frame, right? Because now we are telling it that we want to keep all of the data from the right join, or we can keep all the data from the left, or we can keep the complete cross product, right? And that's what an outer join is. It does a cross product, and on those keys keeps all of the options, which means that it's going to have a huge number of nands, right? Because at this point, rather than saying find me when all the data is consistent and only keeping that, you're saying every possible combination of the appearance of these two keys, of the candidate key or the president key, I want to keep it. And obviously, if there's no matching data, just fill it in. And so an outer join tends to produce, if you have sparse matches between the keys, you end up producing lots and lots of nands in the resulting table. But this is exactly the semantics of joins that we've seen in SQL, and how it is accessible to you in the Pandas merge method, which, as we said, is the only one we're going to focus on. So that concludes our Pandas lecture. There's a lot of content that we've covered in these two lectures, but this is not something that you're going to learn by just watching us. You need to play with the code, you need to play with these notebooks, you need to dig into them, ask questions, experiment, try to see what happens if you change a line of code, and convince yourself that you can understand what the output should be, that you can explain why Pandas is doing what it's doing. And we'll give you lots and lots of practice through the entire course with this very powerful but fairly complex tool. Thank you.